The first question in this tutorial on algebraic indices or exponents deals with the rule a to the power m times a to the power n is a to the power m plus n. So if the bases are the same and we are multiplying two exponents, we add the powers. So in a we have x squared times x cubed. The bases here are both x, and we are multiplying, so that means we can add the powers. So it's going to be x to the power 2 plus 3, in other words x to the power 5. Then in b we have a times a to the 4. What's important to note here is that the first a over here has a power of 1 that we don't write. So once again, we are multiplying two exponents and the bases are the same, so we can add the powers. So it's going to be a to the power 1 plus 4, in other words a to the power 5. Then in c, we have m to the 5 times m to the negative 3. Once again, we are multiplying two exponents and the bases are the same, so we can add the powers. So 5 plus negative 3 is the same as 5 minus 3, which of course is 2. So this is going to be equal to m to the power 2, or m squared. Then in d, we have 3p squared times 4p to the power 5. Here we have numbers as well, so we simply multiply the numbers. 3 times 4 is 12. Then multiplying the p's, the bases are the same, so we can add the powers. So 2 plus 5 is 7. So 12p to the power of 7. In e, we have 4x cubed y times 5x squared y. So we can multiply the numbers. So 4 times 5 is 20. When we multiply the x's, we can add the powers. So x to the power 3 plus 2. In other words, x to the power 5. The same with the y's, so we can add the powers when we multiply. And important to note that the y's have a power of 1 that we don't write. So it's going to be y to the 1 plus 1, which is y squared. Then in f, we have brackets. Now, remember that brackets mean multiplication. And we can start by first multiplying the numbers. So 4 times 5 is 20. Note that the c here has a power of 1 that we don't write, as well as the a over here. So when we multiply the a's, we can add the powers. So a to the power 3 plus 1, so 4. We add the powers of the b's when we multiply. So it's b to the power of 2 times b cubed will give us b to the power 5. And adding the powers of the c's, 1 plus 2 is 3. Let's look at g. We can multiply the numbers. So 3 times 5 over 3 will give us 5. And we can add the powers of the x's. So negative a half plus 4 is 3.5, or 7 over 2. The second question in this tutorial deals with the exponential law that says a to the power m divided by a to the power n equals a to the power m minus n. In other words, when we divide two exponents and the bases are the same, we can subtract the powers. Here we have x to the 5 divided by x cubed. So we are dividing and the bases are both x, and that means we can subtract the powers. So it's x to the 5 minus 3, in other words x squared. In b, we have p to the 7 divided by p cubed. Once again, we are dividing and the bases are the same, so we can subtract the powers. So it's going to be p to the power of 7 minus 3, in other words p to the power 4. In c, we have m cubed divided by m to the power 5. Once again, since we are dividing and the bases are the same, we can subtract the powers. So 3 minus 5 is negative 2. Now, we always try and write the power as positive. So we can write m to the negative 2 as 1 over m squared. Here we use a rule or exponential rule that says a to the negative m is 1 over a to the positive m. We're going to look at this rule in more detail further on. But we can write a negative power as a positive power by using this rule. So m to the negative 2 will be 1 over m squared. Then in D, we have x to the 2/3 divided by x to the negative 7 over 3. Once again, since we are dividing and the bases are the same, we can subtract the powers. So it's going to be 2/3 minus negative 7 over 3. And this, of course, is 2/3 plus 7 over 3. A minus times a minus being a plus, which is 9 over 3, or just 3. So then the answer here will be x to the power of 3, or x cubed. Here we have 8x to the 6th divided by 2x squared. We can divide the numbers, so 8 divided by 2 is 4. When we divide the x's, since the bases are the same, we can subtract the powers. So 6 minus 2 is 4. So 4x to the power 4. Then in F, we have 12y to the power 2 divided by 4y to the negative 3. So we can start by dividing the numbers. So 12 divided by 4 is 3. When we divide the letters here, the y's, we can subtract the powers. And we know that 2 minus negative 3 is 2 plus 3, which is equal to 5. So this is going to be 3y to the power 5. Then in G, we have 4a cubed b squared divided by 16a to the power 5b. Once again, we can start by dividing the numbers. So 4 into 16, 4 times. And that's going to be in the denominator. When we divide the a's and the b's, we can subtract the powers. So a cubed divided by a squared will be a to the power 3 minus 2. So a to the 1, or just a. Then we have b squared divided by b. Of course, there's a power here with a b that we don't write. So we subtract the powers of the b's. So b squared divided by b to the 1 will be b to the 2 minus 1. In other words, b to the 1, or just b. Let's look at h. So we have 3/5 x to the half divided by 3x to the negative 4. So once again, we can start by dividing the numbers. Now, we know that 2/3 divided by 3 is the same as 2/3 multiplied by 1 over 3. And this, of course, is 2 over 9. So 2 over 9. Then when we divide the x's, we can subtract the powers. So we're going to take a half minus negative 4, which is a half plus 4. And we know this is equal to 4.5. So 4.5, or 9 over 2. So the answer then will be 2 over 9 x to the 9 over 2. So this question deals with the exponential law that says a to the m all to the power n is a to the power of m times n, or mn. In other words, when we have brackets, we multiply the powers. So let's look at A. We have m cubed all squared. So we have brackets and we multiply the powers. So we get m to the 3 times 2. In other words, m to the power 6. Let's look at B. Once again, we have brackets. So we multiply the powers. So it's going to be x to the power of 8 times 3. In other words, x to the power 24. Then in C, we have 5x to the power 4, all to the power 3. There are two important things to note here. Firstly, everything in the brackets must be raised to the power 3, so including the 5 here. And then secondly, the 5 here has a power of 1 that we don't write. So that's important to note. So then using this law, we can multiply the powers. So 5 to the power of 1 times 3, so 5 cubed. And then x to the power of 4 times 3. In other words, x to the power 12. Now we simplify this. 5 cubed, of course, is 125. So this is going to be the answer. Let's look at D. Important to note that the 3 here has a power of 1 that we don't write. Then, using this exponential law, we can multiply the powers. So it's 3 to the power of 1 times 3, so 3 cubed. X to the power of 2 times 3, which is 6. Y to the power of 4 times 3, which is 12. Now we simplify this. We know that 3 cubed is 27. Then going on to E, what's important to note here is that both the 4 and the A have powers of 1 that we don't write. So now we can apply this exponential law and multiply the powers. So it's going to be 4 to the power of 1 times 4, so 4 to the power of 4. A to the power of 1 times 4, so a to the power of 4. B to the power of 5 times 4, so b to the 20. We know that 4 to the power of 4 comes to 256. So this is going to be our final answer. So important to note to always simplify numbers raised to a power in this type of problem. Let's look at F. We have 27 x to the power 9, all to the power 2/3. Now, what we're going to do here is we're first going to write the 27 in terms of prime factors. So we know 27 is going to be 3 cubed. This is finding the prime factors of 27. Now we can use this law and multiply the powers. So 3 times 2/3, of course, is 2. 9 times 2/3 is going to be 6. Now we simplify. 3 squared is 9. So 9 times x to the 6. Once again, we can write 81 in terms of its prime factors. So we know that 81 is 3 to the power 4. Now we can use this law and multiply the powers. So 4 times a quarter is 1. So we get 3 to the power 1, which is 3. Then 16 times a quarter is 4. So it's y to the 4. So this question deals with the exponential law that says a over b all to the power m equals a to the power m over b to the power m. In other words, when we have a fraction that's raised to a power, we can apply the power to both the numerator and the denominator. So let's look at a. We have x squared over y cubed all to the power 4. So we can use this rule and apply the power of 4 to both the numerator and the denominator. And remember that when we have brackets, we multiply the powers. So this is going to be x to the power 2 times 4. So x to the 8 over y to the power of 3 times 4. So y to the power of 12. Let's look at B. What's important to note here is that the P has a power of 1 that we don't write. Then applying this exponential law, we can apply the power of 2 to both the numerator and the denominator. So it's going to be P to the power of 1 times 2, so P squared, over Q to the power of 3 times 2, so Q to the power of 6. Going on to C, important to note that the 2 here has a power of 1 that we don't write. So does a 3 over here and the n over here. Now we can apply this law of exponents, and we can apply the power outside the brackets to both the numerator and the denominator. So it's going to be 2 to the power of 1 times 2, so 2 squared, m to the power 3 times 2, so m to the power 6. Then in the denominator, it's 3 to the power 1 times 2, so 3 squared, and n to the power of 1 times 2, so n squared. We can simplify this expression, so 2 squared is 4, and 3 squared is 9. Let's look at D. We can start by writing 27 in terms of its prime factors. We know that 27 is 3 cubed. Using prime factors, now we can apply this law. We can multiply the power of the numerator by the power outside the bracket. So x to the power of 6 times a third, and of course 6 times a third is 2, so x squared. 3 to the power 3 times a third, so 3, the power here, times a third is 1. So it's 3 to the power 1, or just 3. Then going on to E, we can write both 8 in the numerator and 125 in the denominator in terms of their prime factors. We know that 8 will be 2 cubed, and 125 is 5 cubed. Now we can apply this exponential law and multiply the powers inside the brackets by the power outside the brackets for both the numerator and the denominator. So here we have 3 times 2/3, which is going to give us 2. So we're left with 2 squared. Then 9 times 2/3 will give us 6. So p to the power 6. 3 times 2/3 will give us 2, so we have 5 squared. And then 6 times 2/3 here will give us 4, so q to the power 4. We can simplify this, so 2 squared will give us 4, and 5 squared is 25.